All right, welcome everybody. We're going to wait a few minutes. Others finish logging on, so we expect to get started in just 2 minutes. For those of you who might have heard the end of our last conversation, there's a secret handshake for free ski trips for every million Trackpads that are done. So, but you have to stay to the end of the webinar to find out those details. All right, so let's see. We're at the moment. So let's go ahead and get started. So good afternoon, everybody. I am Stuart Nixdorf, and I'm going to kick off today's webinar, which is Building Piezo High-Definition Haptic Trackpads for Premium Computers. We've got two subject matter experts here today, Danny Meunier, our Director of Business Development at Boreas Technologies and our Category Manager, and then Ethan Sturm, who is the Senior Marketing Manager for Circ, one of the market leaders in the trackpad market. In today's presentation, we're going to be covering a few key topics. First, why are major consumer markets shifting to piezo high-definition haptics? The future of the trackpad and upcoming trends, piezo trackpad key success criteria, a question up for debate, which is creating the perfect click. How do you do it, and can it be done? And then most importantly, we want to try to make this as interactive as possible. We're doing the webinar as a poor surrogate for in-meeting, face-to-face meetings, but we do have some new concept systems and reference designs coming, so you'll get a chance to see those, but please try to make this as interactive as possible. So as a short introduction, I'd like to start off with a background on Boreas Technologies. So Boreas is a spin out of Harvard University, based on a breakthrough technology that was identified in 2013 to unlock the piezo actuator or the piezo capacitive drive market. For many, many years, piezo actuators have shown the promise of higher definition, lower power, unique form factors, and smaller size, but they've been unable to go into consumer markets because of the power drive electronics that were 2 or 3 times as larger or power hungry as the actuators themselves. Our breakthrough technology unlocked that market segment. And since 2016, we've been focused exclusively on this future of feel, on how to sense, touch, and create user experiences with piezo actuators, both for force sensing and definition use cases. One point that's important for this presentation would like to bring up is one of the unique technologies you can do with piezo actuators and with Boreas is that you can be both an actuator and a force sensor. Many of our market segments, people are reducing the bill of materials, doing high levels of integration, saving on size, and increasing manufacturing yield by simplifying the design to use a component like ours in both the sensing and actuation for haptics devices. And today we're going to be talking about trackpads, but this market is shifting. All markets are shifting for what we see as 2 macro design trends. First is what we call displayification. Every and anything is being covered with a display. A large display, a curved display, a flexible display, foldable display, and that's making these clean, beautiful product designs. But sometimes it's at the expense of customer intimacy. These designs are replacing buttons, tactile senses, ways for the users to engage. And in addition, the devices that people are developing are now with us 24 hours a day, where you're going, whether you're working out, you're going to work, you're traveling, that there is some electronic device with a large, clean, beautiful screen that's trying to be personalized and localized with you. So what we're able to do with high definition piezo haptics is duplicate human interactions, make things subtle and realistic, make them personalized for the person, or to be specific for the individual apps or use cases that users are using the products for. We've got a number of stats off to the right you can look at later, but we just want to highlight that the market is quickly shifting to piezo against the older technologies of LRA and ERM. The over 75% of consumer-facing devices are adding haptics. We're seeing that going deeper in segments. And in a time when people are focused on reducing bill of materials, they're still increasing the spend on haptics because that's a way to differentiate their products and make the products more useful for the consumers that are buying them. For us, we're lucky enough to be working in several market segments. We work in PC, smartphones, wearables, and automotive IoT, and we're able to take the best practices of what we learn in each of these market segments, partner with unique market segment experts like Circ, and focus the technology into a market-specific or customer-specific application. We've been working not only on the on the integrated circuit side, but also on industrial design implementations, reference designs, and concept systems. And we see from the attendee list that at least a third of you, if not half of you, are actually in automotive or in wearables or other market segments, not just trackpads. And so this is an opportunity for you to get best practices, but today we're going to go deeper in trackpads in that market segment. So the big question we're going to try to cover today is this the turning point? Is 2021 the year of the haptic touchpad? And I'd like to turn the presentation over to Ethan.
Thanks, Stuart. It's great to be with you today. I think we are really excited about this being a transition time. And that's what I'm going to be talking about along with Stuart and Danny. But first, let me give you a little bit of background on who Circ is. So we're the first company to really commercialize capacitive touch. We were founded in the 1980s by a professor at the University of Utah. He was a big-time skier, and so we still kind of celebrate that heritage. That's where our name comes from. The name Circ was our founder's favorite run at a ski resort here in Utah called Snowbird. So we're still headquartered here in Salt Lake City. We have our own in-house mixed signal ASIC design team. We do our own touch controller ASIC that powers all of our solutions. And we're a wholly owned subsidiary of Alps Alpine out of Japan. And I'll give a little bit more background on that here in the next for our history in some more detail. So as I mentioned, the founders of Circ developed the technology in the 1980s. The company was originally founded in 1991. And our first product for most of that initial decade were desktop touchpads that we sold as standalone peripherals, kind of like that little one you see on the screen there. And if any of you remember the Circuit Cities and CompUSAs at the time, it was pretty common to see Circ devices next to mice. We also got into the keyboard market, and we were pretty heavily involved in that retail space throughout the 90s. But of course, where touchpads really found their application was the notebook computers. And in 1994, the first notebook with a touchpad shipped using our technology. And at that time, we started working very closely with Alps Electric out of Japan, and we licensed the notebook market to them to go after what we targeted some of the other markets. Of course, notebooks ended up being the big market, and we became a wholly owned subsidiary of Alps in 2003. So for the next decade or so, we worked on developing new technologies and new industrial touchscreens, virtual reality controllers, while at the same time still doing core technology development that Alps Alpine used in the notebook space. And then the big shift for us happened in 2020 when Alps transitioned that high volume notebook business back to Circ exclusively. So we now have taken control of that business. We're working directly with all the notebook OEMs, in addition to continuing to do the core technology development. And then this year, we're very excited to celebrate our 30-year anniversary. That's a lot of touchpads, a lot of touch chips that we've shipped. And we're excited to partner with companies like Boreas to do even more in the future. So I want to touch a little bit about kind of the trend of PC input paradigms that we've seen and what that means for the future. If you reflect back a little bit on the big picture of computing interfaces, of course, initially it was all keyboard. We're typing command line interfaces on our monochrome displays, and that's really all you needed. But then the graphic user interface completely changed the paradigm. And when that became the standard, a pointing device was needed. And of course, the mouse was that pointing device and still is that primary point today. But a mouse isn't a great solution for a portable device where you need a self-contained input system. So the first notebook computers that shipped made use of things like trackballs and stick pointers, like you see here on the left of the screen. And the problem with those devices is that they were not very precise. They were also very failure prone. Dust, mechanical issues would impact those devices pretty quickly. So when the touchpad came onto the scene in 1994, it pretty quickly took over the space as the input device for portable computing. And for that first period of time, touchpads were pretty consistent. You had, a relatively small touchpad. You had mechanical buttons. The big innovation that happened at the time was maybe you got a scroll zone on the side, and things were kind of static there for a little while. But then we saw the next jump, and that jump involved multi-finger gestures. Now there was a whole new dimension of interaction that you could have with the touchpad. And because space became much more important to perform these multi-finger gestures, the ClickPad, or the buttonless touchpad, was created to basically integrate those mechanical buttons into the device. So now we've seen touchpads get bigger, more feature rich with multi-finger, and that's kind of been the paradigm now for the past little while. So I think what's exciting about what we're talking about today is we're really on the cusp of the next paradigm for no PC computing, which is, of course, haptic and force. So stepping back from that a little bit and looking at some of the big picture trends that we see in portable computers, kind of the big three macro trends that we see is thin and sleek. And this has been happening for a couple of years now with Intel's Ultrabook initiative. This is an obvious one, right? We want our computers to be portable. We want them to be easy. They're portable computing devices. The lighter they are, the better. But at the same time, we demand more of them. We need high performance. We need all-day battery life. And there's a conflict there because you're trying to put bigger batteries in systems that need to be thinner and lighter. So there's trade-offs there that we're always trying to resolve. Millimeters of space are critical in these devices. And right below the touchpad is where the battery is. So there's a direct correlation there. And then at the same time, notebook OEMs are working hard to differentiate their devices. How can they be more delightful to the end user? No one wants just the big gray box that really was the design standard for many years. So you're seeing things like new industrial designs, premium materials, leathers, woods, things like that. That's becoming more and more common. And so anything that we can do to support that from the input side is also important. The other big trend, of course, that we're all painfully aware of is remote work. Thanks to the COVID pandemic, most of us went remote. Many of us are still remote, and the projections are that will continue. For some people, they'll stay remote. Others will switch to a hybrid model. But the data from Reuters from this particular study was that post-COVID, 31% of the workforce was going to stay as per employees. Notebook PC sales exploded during the pandemic, and that was to support all of these remote workers. So portable computing devices are going to remain a hot commodity. Video conferencing, of course, is huge. As you can see, Zoom had a massive increase in users, and that was just one platform. So we saw suddenly an emphasis on higher quality cameras, higher quality microphones. Those were an afterthought at one time for some systems, and now they're really a critical feature. So what can we do from the input side, again, to support remote work? Same with remote learning. How do we keep children engaged as they're using these devices more than maybe spending time in the classroom? So those are kind of some of the big macro trends, and Piezo trackpads, haptic trackpads, force trackpads, and Piezo in particular really enable a lot of those. One of the biggest advantages that we see with Piezo technology is how thin it is. Stuart mentioned other haptic actuators that have been common, things like LRAs, ERMs. ERMs are the eccentric rotating mass, the old buzzy cell phone haptic that we had for a long time. Those were never really a possibility for LRAs have been used, but LRAs are very thick. And as we talked about, there's any objects that you put under the touchpad are just going to eat into that space that you need. So Piezo is huge. The thinness aspect is tremendous. And then the ability to support better user experience, both through configurability in software and flexibility in design. Piezos come in many different shapes and sizes. They can be configured to provide different kinds of feedback. And so suddenly we have many, many more dimensions of interactivity available. And so that's what I think we're going to talk about next, is get into some detail about exactly how the technology enables that. So before we jump into that, want to talk about kind of the key success criteria that we see in order for a haptic trackpad to be successful. And really, at a minimum, we need to be as good or better than the best ClickPad. If someone picks up a notebook PC and it's got a poorly implemented haptic pad that has a poor click, maybe it's got a tinny sound to it, it's just a compromise versus what they had before, then obviously that's not going to fly. We need to be better. And so that's the minimum bar that we're targeting. But then once we meet that, there's so many other advantages that we get with the technology. We have no more mechanical structures, hinges, switches that get loose, wiggle, squeak over time. That's all gone. And then, of course, because it is a dynamic haptic feedback, we can do so much more than just simulate a click. We can provide rich feedback to the user and also provide the variable levels of force as another input. So I think we're going to get into those details next. Danny's going to dig into that. We do have a question. Stuart, I don't know if you want to take a look at that and address that, or
a tactical question. We will be sending out the presentation to everyone, so they'll get all of that as a follow-up. So, thanks, Ethan.
Yep, for sure.
All right. And Danny, tell us about the key success criteria.
All right. Thanks, Stuart, and thanks, Ethan. So thank you all for attending this webinar today. So yeah, let me start and say a few words about the solution itself and what we are actually with Circ right now. So the solution that we're working is a complete trackpad solution that is controlled with the Boreas driver and actually with a single haptic controller. And the main two advantage of that is that we are force sensing the pressure from the piezos, and we are also playing the haptic effect to those piezos using actually one single IC, which is the Boreas driver. So as previously mentioned, the trend for trackpad is to go bigger and bigger in time. So our platform will support very large trackpad size up to 160 by 100 millimeter. And it will also allow ultra thin solution, as Ethan mentioned, below 2.8 millimeter. So that will certainly allow a lot more spaces for the batteries to expand and have capacity in computers. All the electronic that is part of the touch IC is below the PCBA. So I'll mention about the layers of the solution a little bit later on, but basically all electronic coexist with the haptic piezo solution on the backside of the PCB. So it's kind of a fight between the mechanical engineers and between electrical engineers to do some compromise for their keep out areas on both sides. So everything is also adjustable as far as force sensing thresholds, haptic strength. It is all configurable by the software and by the user. And also, thanks for the Touch IC from Circ, it supports the PTP standard actually.
Yeah, Danny, if you don't mind, maybe I could touch on that real fast for some that might not be familiar with PTP. So that stands for Precision Touchpad. And that's a Microsoft initiative that launched a few years ago to kind of standardize the Windows touch experience. For many years, everyone in the touchpad space had their own driver. We had our own driver. Our competitors had their own driver. And so Windows touchpads had their own kind of feel, which was one of the criticisms in this space. You could pick up an HP and it would kind of feel differently than a Dell. So Microsoft a few years back launched this Precision Touchpad initiative where basically they pulled that functionality into Windows so that they could make it common across any OEM's platform. And then also there's a minimum quality bar that PTP touchpads have to meet. There's testing that they undergo to make sure that the latency is low enough, the gesture performance is good enough. And so really PTP is kind of the standard today. It's what customers expect. And pretty much everything that we ship is a PTP touchpad. So that's built into our touch controller, and it will be supported by everything that we're doing with Boreas.
Yeah, thanks, Ethan. So another aspect to talk about is the all about the challenges and all things to consider when you design an haptic trackpad. Of course, there's many requests for having the best force sensing uniformity and the best haptic intensity uniformity across the entire touchpad area, and those two, especially on the force sensing, can be either controlled by design and also by the software in conjunction with the position of the finger and the touch IC event that the Boreas driver knows. The force sensing can be adjusted from the position of the finger. The other aspect is also very important to consider is the system latency. Actually, there's 4 events that are involved when you press and generate a click response to the human. So you have the finger to press, and then once the threshold has been reached, we are playing a press click. And once the finger gets released, that's another event to trigger the haptic release click event. So all these events needs to be quite quick between the touch IC and the Boreas driver, so the system latency is quite low. On the piezo choices, there's many. If you compare previously, if you look at 2 years ago, there was not so many suppliers for piezos. Now there is more and more on the market, and there's more choices. So you have, for example, single layer piezos, multi-layer piezos, and also in different shapes. So in disc, in bars. So the choice of the piezo is quite important in the solution, and you will see that with the different mechanical integration that we are making with those, you can have different click sensation. On the design architecture as well, as I mentioned before, keep out area. So you need the haptic layers to be below and coexist with the electrical BOM. You need to design for a good manufacturability. So it's quite important that all the variation in the system, you have a repeatability on the force sensing uniformity and haptic uniformity in the manufacturing. So we are taking that into account. You need to design for testability. Very important. You don't want to see yield with 6% at the module assembly house. So you need to have a good yield so that you don't need to tune the haptics to recover bad uniformity, for example. You need to design it for reliability. Again, you need to make sure you are putting hard stop to protect the piezo. You need to make sure that it will pass the drop testing. So everything is robust and reliable. You need also a flexible solution. So some system will prefer a bottom-up assembly process, and some other systems will prefer a bottom-down assembly system. So flexibility is important, and of course, the cost. So for those who are not very familiar with this design architecture of a haptic trackpad, it's quite simple. If you look at this way, it is usually 3 layers. So you have the top layer where you have the either a glass on the top surface or a membrane that is attached to the PCBA, which is actually having on one side the force sensing solution, and on the other side all the electronics on the back side. And then if you look at the 2 other layers, what you can see in blue is actually where we integrate the piezos and all the mechanics and solutions to handle the haptics. And we call this layer the haptic layers. So what you can see here is as V1, V2, V3 is just to show you that we are working on a platform that will allow the user, that will allow multiple different designs. And of course, on the very last layer, you have the bracket to support the entire module, and also will act as the attach method for the system level. So on the electrical side, it's combining the touch IC communication with the Boreas driver and the piezos to give you a kind of a real force and haptic solution. So here's the fun part, and I guess we're going to discuss about that a little bit more in interaction between the panelists. But how to create the perfect click? As I mentioned before, the very minimum of the first generation of haptic trackpad will be to create a very good click effect, and there's many metrics that are involved to create those to create the perfect click. So some people will say, okay, you need good acceleration, for example. So acceleration is one metric. However, we have experienced that in some case you can create an haptic trackpad that can provide 10 Gs of acceleration and another one with 2 Gs of acceleration. When you feel the sensation, people will say, well, the 2G looks to me that is producing more force. So it's not just about the acceleration. So force is also important. Sound, acoustic sound is also a very good metric and very important metric to consider, because you can have a good sensation, but if it's producing noise, you can feel like a cheap solution or not good solution. The shape of the click is also important, so we can play with that. We can play with frequencies, amplitudes that we are forwarding to the piezos. These are also adjustable parameters. And on the haptic mechanics, that's the portion of the design that is quite also important, because this is where it takes the electrical signals and converting into a movement, an haptic movement, and an haptic signal to the finger of the user. So the mechanics needs to be very, very, very controlled. And why we are saying at Boreas that it is our advantage is because inside our platform, we offer tunability from the design, from the different designs that we have, and also tunability by the user in the software, actually. So let's wrap it up here with the evolution that we can see on the market for the trackpad. As we mentioned, we all believe that the first step will be to create that perfect click with a good solution for the haptic trackpads. So that would be the first natural evolution of the trackpad. And guess what? I mean, the haptic will come as a bonus. So as you create the perfect clicks, the all other haptic effects are for free. So so it's natural to see that the next step will be to add haptics to gestures, and hopefully that we're gonna see new version of the Windows PDP standard that will allow those extra communication to the user. And then, as we said previously in the presentation, why don't we extend the trackpad to the entire palm rest area? We can do sleeker designs, and we can have this entire area to be more productive, so to have a better input device for the laptop, and also a better communication back to the user with haptics. And at the end, we can add also other applications. So if you can see that the trackpad could be a display, you can add an haptic stylus or an haptic pen to this function, and you can have a display. And we also see foldable display that could cover up the entire laptop, actually, in some cases. So any comments on the evolution, Ethan or Stuart?
Yeah, no, I think think great. And yeah, totally agree. So, kind of as you said, and as we've been saying, first approach out of the gate is we want to get this perfect click, a really good ClickPad experience using haptic and force. But there's just so much more that you can do with the technology. And that's what's exciting about what may be coming. We hope to see Microsoft support new features in the operating system, because you can imagine the type of interactivity that might be possible. Now, instead of just basically a passive input device, you could get feedback from the user interface. Maybe when you scroll over certain windows, you scroll over dialog boxes, you could feel that versus it just being a passive experience. You can imagine a two-finger scroll gesture that simulates a mouse wheel. All those things are possible now. For many people, the touchpad is kind of a compromised device. It's what they use when they're on the road, when they need to use their computer portably, when they don't have a mouse, and it's great for that purpose. But what can we do to make the touchpad experience even better than a mouse? And this type of feedback that's possible is one of those things that this technology enables. Force, of course, is huge too. The ability to have different brush sizes in a graphic application. Possibilities there are endless. And then on the display side, kind of that far evolution, like Stuart mentioned earlier, this displayification, we expect that trend to continue in computing as well. We've seen concepts of foldable PCs and full screen PCs. And for that, the type of device to really be successful, you're going to need a perfect tactile haptic experience such that, a mechanical keyboard are needed. And so we're kind of setting the work for that now. And, obviously that's something that's in the future, but this technology makes that sort of thing possible.
Excellent. So guys, there's been quite a few questions. Some of those are specific on other markets other than trackpads. So we'll hold those for private answers, but a couple of them here I want to get your opinion on. One of them is, sorry, my glasses are out of focus. When we talk about tunability of the design, as Danny mentioned, and tunability of the software, and Ethan, I think you mentioned this as well with like Windows, and I know we see this in like mobile gaming. If somebody has a driving or somebody has a role player game, they're actually trying to customize the experience or the kind of the haptic feel from the software all the way through to the user. But how does that happen with a trackpad, or how do you see, looking back and guessing forward, how do we evolve? Will Photoshop let me feel a pencil or a pen, or what happens in the future?
Yeah. Let me jump into that first, and then I'll pass it over to Danny. So I think at a very basic level, what we're talking about here is the ability to control the intensity of the haptic and also the intensity of the force that's required, which is something that isn't possible today with mechanical designs. Your ClickPad click force is what it is. It's built into the hardware. It's based on what kind of switch is selected. It's not configurable. With this, the user can completely change that. If they would rather have a heavier force, maybe they're accidentally clicking their pad they find when they use it, well, turn up the force threshold that's required. Maybe they don't like how intense the haptic is. That can all be adjusted. So that's, again, kind of addressing that basic, how can we make a better ClickPad? But then beyond that, these use cases that we've talked about, the ability to give user feedback based on what's happening on the system, the limit is really endless there based on what comes in future operating systems and future drivers. So I think that's, from the software side, there's a ton of flexibility. From the physical design side of the pad, there's a lot of things that can be done based on piezo design decisions, different types of piezos, different placements. Danny, maybe you could speak to that a little bit.
Well, as far as tunability, we hope to see that those parameters will be selectable in the operating system from Windows, right? So from a light pressure threshold to a heavy pressure threshold for the user that would like to have light sensing, or they would prefer to push harder to get the click sensation. So those threshold value could be adjusted by the software, for the force sensing, and the same thing on the haptic. If someone preferred the click to be strong or to be very light, this is something also that will be either adjustable by the software, by the operating system in terms of percentage, or kind of a light, medium to heavy haptic strength.
Thanks, Danny. And we have another question here. It might be going into a technical deep dive. Danny, let's see if you can take a shot at this. So I know I mentioned LRA is an older technology, might not be the best, but heck, Apple used it. So why can't it be thin? Why isn't that the right choice?
Well, I guess yeah, that's a good question. I think Apple released that in 2015, and nothing was done to reduce the thickness of the trackpad. So there must be a good reason for that. And I guess that it's all because of the complexity that the coil and the internal mass need to be. I think they need to be big to be able to produce the amount of force to get laterally. So the LRAs, the Haptic trackpad using LRAs are using lateral movement, and we are using Z vibration, so in vertical way. So, and thanks for the piezos, because the piezos could be quite thin. I mean, the small piezo disc could be as thin as few hundred of microns. So it's allowing us to do very thin design. So LRAs, I mean, they just can't be that thin because of the electrical construction and the mass they need to make the vibration.
Danny, maybe one more thing I'll mention is that the other advantage that Piezos and the Boreas solution has over LRA designs is the force sensing aspect, right? So an LRA provides the haptic, but in an LRA design, you're still going to need a different mechanism to do the force sensing also. And many of those are thin, but it adds to the complexity of the design. It adds to the BOM, adds to the cost. So the ability to do both the haptic and the force in one device with one IC is a tremendous advantage.
That's correct.
Excellent. Thanks. Well, we are starting to run up against time, or actually, I think the official time was 30 minutes, which we've been about 10 minutes over, 11 minutes over. I think what we'd like to follow up with a few things here. One, as we mentioned, this is one small snapshot of a segment of our business and the relationship when we're working. I guess sorry, we're still looking at Ethan. Sorry, I'll take back over Ethan here. But we also work with mice, stylus, foldable keyboards, and other systems on this. The trackpads are quite important. And then I think most importantly is most of you in the PC space know us, or are people connected well with us and our teams. So we have our contact information here in the presentation. We will send out a link for the video of this, and then we would love to go much deeper with each and every one of you on your particular applications, whether that's PCs, trackpads, automotive, wearables, or other pieces. We can reach out and schedule a private meeting and hopefully start to get some of these samples in your hands. Ethan, thank you very much for your time. Danny, thank you very much for your time. And everybody on the call today, I appreciate your time and great interactive questions and support. Thank you so much.
Thanks, Stuart. It's my pleasure.
Oh, I'd had more questions. I'm going to give a quick check. Okay, I will follow up with those later. Thanks yet again. Bye-bye.